Swayam Prabha. Digital India. Educated India.
Hi everyone, welcome to lecture number 27, the second lecture on compensating wage differentials. In our last lecture, we discussed about the compensating wage differentials and why it occurs in the labor market. We also discussed about the utility function, the indifference curve that describes the worker's choice between the income and the risk jobs. In this lecture, we will discuss about the supply curve to the risk jobs, and also we will discuss about the demand curves for the risk jobs, and this intersection of this demand and supply curve for these risk jobs, how it determines the market compensating wage differential. So, if you remember the last lecture we discussed about that workers care about whether they work in a risk job or in a safe job. And they also care about the wage rate, that what they are going to get in both the jobs, in the risk job as well as in the safe job. So, we define the utility function that working in a safe job or in a risk job, the worker gets certain amount of utility, and this utility is a function of the wage rate which he is going to get and the risk of the injury on the job if he is working in a risk job. So, the marginal utility of income from this utility function gives the change in the utility resulting from $1 increase in the worker's income holding constant the risk on the job. So, we have assumed that workers they prefer higher wages, so that the marginal utility of income is positive, and the utility of the risk gives the change in the utility resulting from a 1 unit change in the probability of injury holding constant the worker's income. So, we define the utility function that it is a function of the wage and also the risk associated with the job. So, we assumed initially that this risk is a bad job, bad. So, the marginal utility of risk is negative. If you remember, we discussed this graph that how we derive the utility from working in a risk job or working in a safe job. So, on the x axis we have taken the probability of risk involved in a job, and on this y axis we have taken the wage rate. Now, at a particular level of wage rate, let us say W0, the utility is associated with this level of W0 wage rate is the U0, and the worker let us say prefers to be at point P because he prefers to be work in a safe job, and working in the safe job getting the wage rate W0, his utility is U0. Now, even if the wage is high like W-1, still the worker prefers to be on this utility function U0, and because going with this W1 W-1 wage rate, and with the probability that the risk is high, and the worker probably may end with an utility function which is U-1, which is lower than this previous utility function. Now, if we are offering the wage rate W-1 to the worker, then definitely he is going to be on a higher utility function u double dash 1, and where the worker will prefer that he should get into this job. So, when we are offering W0, he is of going with this safe job. When we are offering W double dash 1, he is going to in the risk job, and if we were going to offer him a wage rate which is W hat 1, then the worker is become indifferent. So, when we are offering this W hat 1 wage rate and a wage rate W0, so at wage rate W0 he prefers to work in a safe environment. When we are offering at this W hat 1, in the both the cases he is going to be in the same utility function. Now, he becomes indifferent that whether he should work in a safe environment job or he should work in a risk environment job. Now, any wage which is above this, the change, the gap between this wage rate W0 to W hat 1, which is delta W hat, we are saying this is the minimum reservation wage which bribes the worker to get into a risk job. So, the indifference curves that describes a worker's choice between the income and risk of injury, you can see there must be upward sloping because risk is a bad. So, if the worker is currently at point P as we described in the indifference curve, the only way to persuade the worker to move to the riskier job and hold her utility constant is by increasing her wage rate. So, the worker would obviously be worse off if she moved to a riskier job and her wage fall. So, the curvature of this indifference curve reflects the usual assumption that indifference curves are convex. Now, deriving the supply curve for the risk jobs, we can derive the supply curve for the risk jobs from this graph. Now, what happens as we have seen is that at least this delta W hat amount of wage, incremental wage is required, the compensating wage is required in order to bribe the worker to work in a risk environment. So, now if this delta W hat, the difference between W0 and W1 hat, as it keep on increasing, then more and more workers are going to work in the risk environment. So, if we can draw the relationship between the number of employment in risk job, and if we can derive the on the y axis we can measure this the difference between this W0 and W1 hat. So, this reservation wage will be different for different individuals. Now, every individual has some minimum wage differential which accepts that worker will get into a risk job. So, this delta W hat minimum level, now from there as this delta W hat increases, then more and more workers may get into the risk jobs. So, we can derive the supply curve for the risk jobs from this graph, from this utility function. So, then we can see that the supply curve will be upward sloping, and as this delta W hat increases, the number of employment in the risk job will increase. So, this figure explains the supply curve to the risk jobs in the labor market, and this supply curve tells us that how many workers are willing to offer their labor to the risk job as a function of the wage differential, between the risk job and the safe job. Now, because we have assumed that all workers dislike risk, no worker should be willing to work at the risk job when the wage differential is 0. So, as the wage differential increases, there will be we can see a point where the workers who dislike risks, now they at least butt off and decides to work in the risk job. So, this threshold, thus that delta W hat, the minimum delta W hat, this threshold explains the reservation price. So, as the wage differential between the risk and safe jobs keep increasing, there will be more and more workers who are bribed into this risk occupation, and the number of workers who choose to work in the risk job will keep on increasing. So, therefore, you can see that market supply curve to the risk job is upward sloping. So, we have derived that supply curve here, that on the x axis we have taken number of workers in the risk job, and we have taken the wage differential between the risk job and the safe job, and there is a minimum reservation wage rate. From where onwards you can see, as the difference increases, the difference between risk job and the safe job increases, wage difference between this risk job and the safe job increases, the number of workers they are going to increase. So, therefore, the supply curve slopes up, because as the wage gap between the risk job and the safe job increases, more and more workers are willing to work in the risk job. So, therefore, the supply curve to the risk job is upward sloping. Now, coming to the other side, the demand curve for the risk jobs. So, the concept of the demand curve for risk jobs refers to the relationship between wage offered and the number of workers willing to accept a job that involves a certain level of risk. So, in labor economics, the wage differential are often analyzed to understand why workers in the risk job are typically paid more. And further, the pay is known as this compensating wage differential. So, let me give you some explanation of this demand for risk jobs in the context of wage differential. The relationship is there between this wage and the job risk, and when we define this compensating wage differential, this compensating wage differential, by definition it says that workers generally require higher wages to accept jobs that have higher level of risks. So, this additional pay compensation, it compensates them for the increased danger or the unpleasantness in the job. So, now if we want to draw the relationship between wage and the risk jobs, then we can probably derive the demand curve for the risk jobs. So, the demand curve for the risk jobs typically slopes downward, which indicates that a higher wages, more and more workers are willing to accept the risk associated with the job, while as the wage decreases, fewer workers are willing to take risk and get into these risk jobs. There are so many factors which influence this demand for risk jobs and which can influence the demand curve for the risk jobs. First is the level of risk, the degree of risk. The greater the perceived risk of a job, higher the compensating wage differential required to attract the workers. So, the level of risk plays a significant role in determining this wage compensation. Further, this demand for the risk jobs depends on the workers' preference and the risk aversion. Now, the workers' tolerance for the risk, it varies. Different workers have different level of tolerance for the risk. So, some workers may require only a small increase in the wages to accept a risk job, whereas the others may require that a significant amount of premium to accept a risk job. Further, the demand for risk jobs may be influenced by availability of alternative employment. Now, if there are many alternative job opportunities are there in the labor market that are less risky, then workers may be less inclined towards accepting these risk jobs unless the wage differential is quite high. So, the availability of the opportunity plays a significant role on influencing the demand for the risk jobs. Further, labor market condition. Now, when we are saying that the labor market is in a tight situation, means there are fewer workers than jobs. So, the employer may need to offer higher wages to fill these risk positions. So, these are the factors which can influence the demand curve for the risk jobs. And as I said, just as workers they decide that whether to accept job offers from the risky farm or from the safe farms, a farm also must decide that whether to provide a risk or a safe work environment to its workers. So, the farm's choice will depend on what is more profitable, whether the risk environment is more profitable or a safe environment is more profitable. In certain cases, the risk environment is not avoidable, but they try to find that which situation is more profitable, which environment is more profitable. So, while deciding that the demand for workers in the risk job, the farm's choice will depend on that what is more profitable, whether the safe environment is more profitable or the risk environment is more profitable. Let us assume that the farm is going to hire, let us say, E star amount of workers. Now, regardless of which environment it chooses, the farm fixes that it has to hire E star amount of workers. Now, if the farm chooses to offer a safe environment, then the farm's production function, we can say that this Q0 equals to alpha 0 into E star. Now, here alpha 0 is the marginal product of labor in the safe environment and E star is the number of employment. So, if the price of the output equals to P dollar, the value of marginal product of labor in the safe environment will be P into alpha 0. So, with this production function, the value of marginal product of labor is going to be P into alpha 0. Now, if the farm offers a risk environment, the farm's production function is going to be like this Q1 equals to alpha 1 into E star, where alpha 1 is the marginal product of labor in risk environment and E star is the number of employment. So, the value of marginal product of labor in the risk farm, then it is going to be P into alpha 1. So, these are two situations and there are two different production functions and we are having two different level of value of marginal products in the risk environment as well as in the safe environment for the farm. Now, the question is that how does the marginal product of labor differ between safe and risk environment? Now, this is the fundamental question. Now, the answer to this is that safety does not come from free. So, you have to pay for that. Now, the farms has to allocate the labor and capital to produce a safe environment. Therefore, they have to divert some resources from the production of output. Now, this diversion of resources suggests that the marginal product of labor is higher in risk environment. So, in that case, you can have this alpha 1 marginal product of labor in the risk environment is greater than the marginal product of labor in the safe environment. This alpha 1 is greater than alpha 0. Now, it is important to note that if marginal product of labor were indeed higher in the safe farms, then we would never observe anyone working in risk environment. However, it is not only the worker be more productive in safe farm, but the farm would get away with the paying them lower wages because they value safety. So, to understand that why there is a difference in the marginal product of labor in the risk environment and the safe environment, we can see that the farm's decision rate depends on the profit. The farm's objective is to maximize profit. Now, profit is nothing but its difference between revenue minus cost. So, the farm's profit depends on whether it offers a safe environment or a risk environment. Now, if the farm is offering a safe environment, then the revenue is going to be P into alpha 0 into E star. So, this is the revenue and this is the cost by hiring E star amount of labor with a wage rate W0 in a safe environment, the firm is going to have pi 0 profit. Whereas, if the firm is going to have a risk environment, then the revenue is going to be P alpha 1 E star minus W 1 E star. So, this is the cost for working in a having a risk environment. Now, the profit for the risk environment is pi 1. Now, both the revenue and the costs are affected by the firm's decision of whether to offer a safe or a risk working environment. However, a risk firm has greater revenue because more output is produced, but simultaneously the risk firm is also going to have a higher cost because it must pay higher wages to attract workers. So, a profit maximizing firm offers a risk environment if the profit in the risk environment is higher than the profit in the safe environment. Now, let us define the difference between the revenue of these two marginal product of revenue of these two places, safe jobs and the risk jobs, by theta. So, this is the marginal product of revenue P into alpha 1 minus P into alpha 0. P into alpha 0, P alpha 0 is the marginal product of revenue in the safe environment, P alpha 1 is the marginal product revenue in the risk environment, and the difference between these two, let us say it is theta. This theta explains that the dollar gain per worker, how much of gain the firm is going to have per worker when the firm switches from a safe environment to risk environment. So, the firm is going to offer a safe environment if this theta is less than the additional per dollar gain, per dollar loss per worker. Now, per dollar loss per worker is that the cost W1 minus W0. W1 is the additional cost per worker in risk environment, and W0 is the additional cost for having a worker in the safe environment. So, the firm is going to offer a safe environment, safe working environment if this W1 minus W0 is greater than this theta, and the firm is going to offer a risk environment if this W1 minus W0 is less than this theta. This theta is nothing but the difference between the risk environment and the safe environment in the dollar gain per worker. Now, the point is that different firms have different technologies for producing safety, and implying that the parameter of theta differs across the firm. So, different firms have different level of this theta. So, it completely depends on that which environment the firm should choose. It is simply the difference between the revenue and the cost and the absolute profit. So, different firms have different technology for producing this safety, as I said. For example, the universities, they do not have to allocate many resources to the production of safety in order to provide a safe environment for the staffs. So, that you can see the per worker gain is small in this kind of environments. However, in a coal mine, you will find that it is much more difficult to produce safety. So, the productivity gain associated with offering a risk environment in the coal mines are probably substantial and is very high. Therefore, we can derive the demand curve for the risk jobs. Now, as I said, the market demand curve for the risk jobs is derived by adding up the labor demand curve for the risk firms. Now, we can say that if you look at this graph, on the x axis we have taken the number of workers are employed in the risk job, and on the y axis we have taken the wage differential between this risk job and the safe job, and this theta hat is the maximum point. Now, if it is 0, no worker are going to work in the risk environment. As it declines, you can see more and more workers are going to hire in the risk job. So, if the compensating wage differential is very high, then no farm would choose to become a risk farm. So, this compensating wage differential is here is theta hat. So, if the wage differential, compensating wage differential is very high, no farm would choose to go for a risk environment, and there will be no demand for this risk workers. So, at a certain level of theta it will become 0, and as the wage differential between the risk jobs and the safe jobs keep on falling, more and more farms would like to find it profitable to offer a risk environment, and the quantity of demand for the risk jobs and the risk workers will increase. Therefore, you will find that labor demand curve for the risk jobs is downward sloping. Now, finding the market equilibrium wage rate, wage differential for this risk workers, we have the supply function, we have the demand function. Intersection of this supply and demand will decide that what will be the market compensating wage differential to hire certain amount of workers. So, as you can see on the x axis we have taken the number of workers in the risk job, and the y axis we have taken the wage differential, and at a certain minimum level of wage differential, below that no worker is ready to work in a risk environment. As the wage differential increases, more and more workers are willing to work, therefore, we have a upward sloping supply curve, and we are having a downward sloping demand curve as the wage differential keep on declining. More and more farms they find it profitable to switch over to risk environment and hire more workers with risk jobs. And the intersection of these two at point P decides that the farm will hire E star amount of risk workers with a wage differential which is W1 minus W0 hat star. From the graph we can say that this compensating wage differential which is received by the workers in the risky farm is this the W1 minus W0 star, and the amount of workers employed in these risk jobs is E star amount of workers. Now, the point is that if the wage differential exceeds this equilibrium level, more persons are willing to work in risky farms and compensating wage differential will fall, which will lead to a pressure that this compensating wage differential should decline. Similarly, if the wage differential fell below the equilibrium level, then there would be too few workers are willing to work for this risk jobs and relatively to the demand. So, the compensating wage differential will go up. So, this the shortage and exceed of this demand and supply will create some pressure, so that it will reach to the equilibrium compensating wage differential which is W1 minus W0 star. Now, from this point we can draw certain properties that the market wage differential, what we have seen is that the compensating wage differential is positive. Risk jobs pay more than the safe jobs. So, this result follows from our assumption that all workers they dislike risk. Now, if the farm offering a risk environment, they have to attract the workers and they have to pay high wages. The second property we can derive from this discussion is that the market wage differential, which was W1 minus W0 star, as a measure of average dislike for the risk among the workers in the economy, which means we are saying that this market wage differential W1 minus W0 star as a measure of average reservation price. If we are interpreting in this way, then this is not correct. The equilibrium compensating wage differential is the wage differential that is required to attract the marginal worker, which means that is the last worker to be hired into the risk job. In other words, we can say that this equilibrium wage differential measures the reservation price of the last worker hired, and it has nothing to do with the average dislike or dislike of the risk in the population. Now, each worker is hired by the firm at their reservation wage rate. So, as a result, all workers except the marginal worker, the E-starth worker, all other workers prior to that, those who were hired by the firm, they are overcompensated by the market. After all, every worker, but the last worker hired was willing to work at the risk job at a lower wage rate. So, we can say that a competitive labor market with fully informed worker, it provides more than adequate compensation for the risk that the workers encounter in the job. So, while concluding this, we can say that this compensating wage differential, here we are finding that it is positive. So, if the firm wants to hire the workers in the risk environment, they have to pay more. But sometimes, will it be possible that this compensating wage differential may go in a wrong way? Means the risk workers, they will get lower wage rate. Now, if few workers enjoy working in jobs that have a high probability of injury, and if these type of jobs demand there are relatively fewer workers, so the market wage differential will go in the wrong way and the risk jobs will pay lower wages than the safe jobs. We will discuss all these things in our next lecture. Thank you.